So good afternoon, everybody. Yeah, it's a pleasure to meet you here. My name is Chiou, and I'm come from TrendForce, mainly in charge of optoelectronics and display research. I think it's an honor to meet all of you here. Okay, since this is the last session right before the panel discussion, I would like to share something that is a little bit easier, okay, from the perspective of a market trend. Okay, I think let's can discuss about what kind of challenges and opportunities micro LED faces right now in the four major sections. My presentation consists of 6 sections. Okay, the first one allow me to quickly introduce about TrendForce, and from the section 2 to section 5. I will go through the 4 major applications from the glass-based large-size display, automotive display, and also wearable display. Then we will shift to the silicon-based micro LED, which is applied for the near-eye display, especially for the AR glasses. And finally, I would like to conclude my presentation with some latest data regarding to the micro LED chip value in the following years. So the first one is about TrendForce, which is my company. Okay, TrendForce was established in year 2000. So this year we enjoying the 25th anniversary. And we provide the market intelligence service in 5 major areas. Besides optoelectronics and display, we also cover AI, semiconductor, and also like emerging technology and new energy. TrendForce headquarters is in Taipei, Taiwan, and we also have a branch office in Shenzhen, China. So even we are rooted in Asia, but we service the clients worldwide. So if any of you has interest about our service, welcome to get in touch with me after my section. Okay. So we'll go for the first section about the large size display. Here I have a subtopic. Its names, the most important thing for micro LED used for large size display, how to optimize the design, and how to find a niche market. I think that is the most important thing. So let's focus on the design optimization. Traditionally, because the large size micro LED display need to be tiling, but right now most of the backplane size is quite small, maybe only from like a 4-inch, 8.9 or even like a 12.7, yeah. But right now we found that the industry is gradually reach a consensus. They want to make a bigger size of the backplane. Okay, what is the benefit between enlarge the backplane size? Here, allow me to explain with that. If we use the smaller backplane, okay, so we have to tile a bigger size based on N by N. So that means each of the backplane, you need to proceed the very complicated side wiring or like a TGV process, and that result in lower yield and or higher cost. Okay, so if the backplane size can enlarge it to up to like a 41.6, then you can do the second stage, 2 by N tiling. So that means you can put the driver IC on the edge side. So you can totally remove the process for seamless on the individual backplane. I think that is a very efficient approach to lower down the cost, which is a very important thing for micro LED display, and also to improve the yield. And after the product design is being optimized, what is the next step? I think it's to find the differentiation for micro LED large size display. One of the targets should be the very hot topic, which is the transparent display. But because transparent display is so popular, so micro LED is not the one and only solution. For example, right now we have OLED. Even OLED can support relatively low transparency, maybe in between like 30% to 60%. But this is the technology that already approved their capability for mass production. Okay. Another potential technology on the very right-hand side is so-called scattering LCD. This is a technology that triggered by JDI. Actually, they have a very outstanding transparency rate, up to 80%. But the problem is because JDI's operation is not so good. So I am not sure they can really bring